So unit 3 for us, we're going to get heavier into the algebra. So we're going to start talking today about variables. Variables take on several forms. One form they can take on is just a symbol. In other words, we've been talking about numbers having a count and a name. Like 3 inches, we have 3 as the count and inches is the name. Well, we could have 3x, it's the same thing. 3 is the count, x is the name. And we can work with that symbol just like we do any other name. We might have 3x plus 9x, which is going to give us 12x. When we add numbers, first of all, we must have the same name, and we do, both are x. We combine the counts, 3 plus 9 makes 12, and we keep the same name. So what if I had 5x plus 7y? What would I get? Can't add them. I would just get 5x plus 7y. Just like adding 5 inches plus 7 pounds, I couldn't do anything to it. I'd have to stop there. So we're going to go over a number of ways that we can work with those symbols like that as a name of a number. Another thing, another form a variable can take is it can be just a placeholder. For example, if we have formulas, you guys are going to deal with several cutting speed formulas and stuff like that. But you might just have a simple formula like we saw, or we'll see with temperature conversions. Here, the temperature in degrees Celsius is equal to 5/9 times the Fahrenheit temperature minus 32. Here, that F and C are both variables. F is just waiting for us to give it a value. And once we give it a value, then we can use our order of operations to reduce that expression or calculate that out. For you cutting speeds, your surface cutting speed. In feet per minute is going to be, for a round stock, it is going to be your diameter times pi times your RPM divided by 12. Because your diameter would be given in inches generally. So again, pi of course is a number. That's a constant, it's just a symbol for a constant. But diameter and RPM are both waiting for numbers to be put in there so that we can calculate out our result here. The third application of a variable is as a known value, an unknown but given value. And that's going to be in the form of something like this. 3x plus 1 equals 34. X has a given value. It has a certain value. It's just not stated there. We have to do some work to figure out what that value is. But X has one and only one value in that case. It's just something we have to figure out. Up here, the variables D and N, they can take on any value that's reasonable within that application. So they have more than one specific value that they can take on. So for today, we're going to focus on two things. One, we're going to focus on using them, evaluating expressions with them in it. And then we're going to focus on translating words into these symbols, which I think is probably right up there in the top 1 or 2 most difficult tasks in mathematics. So let's start out with using formulas. So we mentioned the formula C equals 5/9 of F minus 32. This is for converting degrees Fahrenheit and degrees Celsius. So today it's going to be roughly 60 degrees Fahrenheit. What would that be in degrees Celsius? We're going to take 60 and put it in there for F, and we're going to calculate it. Once we replace that symbol, that variable with the number, it now becomes just a matter of order of operations. Order of operations says we have to do what first here? Parentheses. 60 minus 32, 28. Now there's nothing left to do inside the parentheses. I could take the parentheses away. And then what? This is going to be multiplied by 5/9. So 5/9 times 28. I'm just going to do it as... Come on, get out of there. I'm just going to do it as 5 divided by 9 times 28. So it's 15.56 degrees. It's degrees Celsius. Or for you guys, you might have, like I said, your surface cutting speed is going to be your diameter times pi times number of RPMs over 12. So let's say that you have a piece. We're talking about turning on a lathe here, of course. You have a piece that has a diameter of 1.5 inches and is turning at 200 RPM. So now you got to put in 1.5 times pi times 200. That's going to be divided by 12. Order of operations here says you do everything on top. Get the answer, then you're going to do the division. So I'm going to do this all in the calculator. 1.5 times pi, I'll just use 3.14 times 200. So I get that number, 942, divided by 12. So it's 78.5. That is feet per minute. Is my surface cutting speed. Any questions? That application you guys have all seen before? Just
replace it like 3.82 times diameter, or times surface feet divided by diameter. That's the set.
You're trying to find the RPM.
Yeah.
Yeah. What you're doing is you're taking this formula and you're rearranging it.
Right.
Instead of finding the actual surface cutting speed,
Right.
you're saying 12 times the speed divided by the diameter times pi is equal to your number of RPMs.
Right.
Now what you guys do is you just take 12 divided by pi, 12 divided by 3.14, which is your 3.82. And you use 3.82 in there to shorten up the formula. So yeah, here, let's say that you have a material that is capable of a surface cutting speed of 115 feet per minute. And it has a diameter, well, let's say you're going to use a mill on it, and you have a mill that has a 3/4 inch diameter. So you're going to do the same thing. This is going to be 12 times 115 over 0.75 times pi. Now this one's going to be a little bit more difficult to enter into the calculator. I'm going to have to use parentheses on this. So I've got the 12 times 115 on top, divided by, but now when I'm dividing by and there's two things on bottom, I have to make sure that those things get multiplied before I divide by them. So on bottom, I'm going to have to do the 0.75 times pi in parentheses. So 0.75 times 3.14, put in parentheses. Now it would give you that you can go up to 586 RPMs, it looks like. So 585.999 RPM. Equal that. Now again, like I said, you guys do the 3.82 times your speed over diameter. So then you don't have to worry about the parentheses because there's only one number on bottom. You can just do 3.82 times your allowable surface cutting speed divided by your diameter. The next skill with these variables is the one I want to spend the most time on today, and that is translating words into formulas. Let's say I tell you that we have a number increased by 7. What's that going to look like in symbols? I can do x plus 7, I can do n plus 7, y plus 7. Whatever letter I want to use for that variable, I can. So any letter plus 7. Now, other phrases that would give me that exact same expression, and there are a lot of them, might be 7 more than a number. Even though a lot of people say, well, the 7 comes first, wouldn't it be 7 plus x? And it could be. I mean, when you add, the order doesn't matter. But 7 more than something technically indicates that 7 has been added to it. So that'd be x plus 7. Any others that you can think of that would indicate x plus 7? There's a good one. Sum of a number in 7. A number plus 7. Right, this will go straight to the teeth, right? Or 7 added to a number. Or a number with 7 added to it. There are a lot of phrases that would indicate x plus 7. 5 less than a number. Obviously, what operation is going to be happening here? Subtract. Is it 5 minus x or x minus 5? Careful. X minus 5. 5 less than is indicating that 5 has been taken away from it. Now, if it said 5 less a number, that's saying 5, and then we're making a number less than it. We're subtracting the number from it. So that would be 5 minus x. It looks very similar, but it's not, because this is 5 less than a number. Yeah. Less than the number means you're taking 5 away from it. 5 less a number means it's 5, and you're taking the number away from it. So it's a very subtle difference. You have to be very careful. Other phrases that might indicate x minus 5. A number decreased by 5. A number reduced by 5. A number minus 5. Take 5 away from a number. The difference of a number and 5. Now here again, this one, a difference is just the result of the subtraction. You have to put them in the order they're stated. So the difference of a number and 5 indicates x minus 5. If that was the difference of 5 and a number, it would indicate 5 minus the number. How about multiplication? Well, I'm going to go for the obvious one here. 3 times the number. So that one is going to be 3 times x, or just 3x is 3 times x. Could be x times 3, that would be fine. Any other phrases that you can think of? The product of 3 and a number. A number taken 3 times. 3 multiplied by a number multiplied by 3. Notice when we multiply or when we add, the order doesn't matter. You can switch the orders because 3 plus 5 is the same as 5 plus 3. 3 times 5 is the same as 5 times 3. When we subtract, you can't do that. The order does matter. So you have to pay special attention to the order when you subtract and also when you divide. A number split 4 ways. What's that going to be? X divided by 4. Or x over 4. Remember we talked about fractions are kind of a division. Fractions and division are interchangeable. Other phrases that might indicate x divided by 4. Quotient. Quotient of a number in 4. You're the first student I've had in a couple years that actually knew all 4 of the names for those. And he actually paid attention while he was in high school. Makes a big difference. I'm a number divided by 4. Four goes into a number. There are a few phrases for that. So let's make it a little bit more complicated. How about 7 times a number increased by 4. What's that going to be? 7n plus 4 or 7x plus 4, 7y plus 4, whatever, right? 7 times a number is 7n or 7x, whatever. And then increased by 4, you're adding 4 to it. Okay, I want you to try a few in your notes. I want to see how these go. Five more than 3 times a number. Three times a number increased by 5. Five more than the product of 3 and a number. Three times the sum of a number and 5 and the sum of 5 and 3 times a number. All of these are very similar, but they're not all the same. Start with the first one. 5 more than 3 times number. Well, 5 more indicates we're adding 5 to something. What is it we're adding 5 to? 3x, 3 times the number. 3x, 3n, 3y, whatever. 3 times the number increased by 5, what's that going to look like? 3x plus 5. So those two are the same. 5 more than the product of 3 and a number. Well, 5 more means adding 5 to what? 3n, 3x, whatever. 3 times the number. So far, those first 3 are the same. You're going to fight over whether it's x or n? Now this one, 3 times the sum of a number and 5. Very subtle difference here. But you'll notice up here it is 3 times a number. Down here it is 3 times the sum. 3 times a number means you're multiplying that missing number by 3. Here, though, we're multiplying the sum by 3, which means we must do the addition first. The sum is the result of an addition problem. So the sum of a number and 5 is x plus 5 first. How do we indicate that we have to add them before we multiply? Parentheses. So 3 times the sum of x and 5 is 3 times x plus 5 in parentheses. And then finally, the sum of 5 and 3 times the number. 5 plus 3x or 3x plus 5, either one. Any questions? Okay. This one here? Yeah, the sum, if 3 times the sum means we're multiplying a sum by 3. The sum is the result of an addition. So that means we must have done the addition first, so we can multiply its result by 3. So to make sure that we do the addition first, we have to put the parentheses around the x plus 5. That's saying add those first, then multiply by 3. It's a very subtle difference. Anybody have all 5 of those right? Okay. Well, since I am losing my voice very rapidly, we are going to go ahead and give you guys some problems to work on. This is in the big book. We'll be done with packets for a few days. Page 322, exercise 12-2, and page 364 through 366, exercise 14-3. So you got the last 25 minutes or so. If you want to keep working on your test, you can. Or if you want to get started on the homework, go for it.